with my last bag. Oh shit. just, right, okay, that's ready then. Oh, I found another piece of cloth that I haven't put on, so I'll take all the rubber off. Yeah, I knew that it was the last chance. Yes, this is my last one. There was another which can't be corrected. So kind of stuck. Things as they are. Got it to work. It's not ideal. Basically, I had some lines from there's nothing I can do about it. I might try and paint over the top. They're the 3D printer lines. I might try and paint it, the rubber won't stick to itself. So the fact that I've used it today means that I have managed to get it. But it means that it took me 6 hours to get it, which is why I'm doing this. Something that I came across doing something similar. That was it. And he just said, if it fucks up, then fuck it up the whole way. Don't stop when it fucks up. Keep going, because you'll learn the lessons down the next step where, it's like, oh, that's not right, it's not fine, I've got to do it again, I'll throw it away. Yeah, but, that just means that you get to find a new thing. You kept going, you have to have dodgy stuff in between, I realised that I kind of need to become a panel shop for a little bit of time. I need to mass produce these panels because I've got these to do, I've got the CNCs to do, I've got the batteries to do, I've got drawers to do. A lot of panels, and I don't care how they turn out, but you know, in this order I've got wood veneer coming, so if I can learn the lessons and get good, some static electricity going on, you know, if I can get halfway decent, then maybe the first time I do every time I take the gloves off. Oh, now I need to do this bit. Doesn't look Good. That's exactly it. Different thing to that, but it's on low pressure rather than a high low pressure, so I get to manipulate it. And oddly enough, the things that I've got the most control over are on the surfaces inside, which won't be seen, the surfaces outside. I'm not actually controlling as much as I could. That might be something that I'll learn for next time. Do the bits you can see rather than the bits that you can't. Nearly there. It's under control now, so scary bit is done. Let's check that it's reasonably straight. There'll be many writing things. Just bought some more. Bought some more metal rulers as well. Metal rulers, like £1.50 for 30 centimetre at the moment. About, I would use them for cutting. Whenever you're cutting, you can normally cut in a plastic wood. So yeah, two but it's so much better than getting one of these long steel bars with no measurement marks. Right, pressure up. Right. Orange juice and water. About 40 minutes. Feels good. Made like more like cheese in that it's made and wrapped in cloths, and in so much more so even as we roast I've got some. I've got the honey roast down here. As soon as I open the torch on face, go, no. You gave me torch. I know there's 4 pieces in the pack. We've only had 1. What are you trying to pull? What are you trying to pull? Said that you haven't been out as much. You were going out for the sake of going out and scouting and driving around to find out where you could drive around next time. one of the boxes. It sat there for about 3 days. Trees are bold and I can see across the park. Anyway. Talk about what you're going to have to give up for global warming. Martin's got a friend that has been diagnosed with very severe food cancer a month ago. All expecting him to die. Martin is expecting him to die any minute now. But Dr. John Campbell on the YouTube channel did the thing just a couple of days ago that was turbo. I knew it. He did one day which was just titled CN. And then the next day or 2 days later he issued one that had 4 letters in it. Just make up all over it. And it's surgeons that are, being presented with patients to treat that have got 2 cancers at once, and they're immediately in their advanced stages. Whereas that doesn't usually happen. It's like 1 in 1,000 you'll get, something. First time they notice, they'll check it out and it'll be stage 4 cancer. 1 in 1,000. 1 in a million that they come along with stage 4 cancer and another cancer. Yeah, but since all this COVID shot, it's like instead of 1 in a million, it's 1 in 50. 1 in 50. And Martin's friend is, in that exact range. Perfectly healthy, all that kind of stuff. Early 60s. Feeling a bit off, goes to the thingy and he's got, liver and spleen and something else cancer all at once. Very optimistic. need to spend more on the NHS even though they don't do anything, so we're going to borrow it and we're going to reclass debt as investment. Because I was smart enough to put off that rather than taking the whole thing. Anything else about it? No one. I'll be sensible about it. I was right that one time. I was like, oh, I'll just get something like that. thing is, well, it isn't intended to be. Very, very fast. I use this one later on when we create our own stories. There's no need for a resin track this large. You get thermal, run away. Once it's mass, it's usually doing that. I think we will probably be doing rectangular, square, so that you can have nice and low stuff, and also use it for projects, which we do at some point. And they're not too distant future in our time. In the real person's time. Here's one I used earlier. Oh dear. That's never good. 30. So if I do 150, I need 100 to 30 plus 50 to 15. So I need 150 to 30 plus 15 is 45. That brings me up to 200 quite nicely. We still have some spare. So 150 of this. I'm going to need the other scales because these don't cope with more than, maybe they will. Okay, 150 of this. Slow. Slow. Cats are circling. Try not to look at the cats circling. 150 of that. And then we want 30 of the other. Off. Whatever that means. Right, stand by with the obligatory. The toilet paper. And we've got 30, 100 to 30, we've got 45 of this. So we're just under the 200 limit. Let's see, 45. Okay. 1% out. 1% when it's 30% is a third of a percent out. So don't get too anal about things. Boy, where's my mixer? My mixer's usually in my silicon mat. My silicon mat covers all kinds of sins. I didn't drop test this time. This is holding. I don't know how this is holding. This is crazy that it's holding. But it's holding. If it leaks in there, it will get captured in there. It doesn't enter the bag, so it's not. It's just going to make the pump run longer. So I'm not going to die over it. Come on, mixer. There you are. Right, this is my highly technical epoxy mixer. Yes, I do have the things that are 30 quid with plastic bits on it that are designated proper epoxy mixers. They're not as good as this, which was £2.99 in a pound shop. Maybe not. Silver Cross. I need to find some more of these. We'll of course be editing that out. And that. Make sure you touch the sides. Touching the sides, mixing, the more viscous the liquid is, the harder it is to mix. The more air bubbles you'll get in, the more you have to scrape off the side. If it's wet, it's probably going to unwet itself. Much more quickly. I will need to change the charge those batteries. What you can't see, because I've moved it, scientifically measured amount of white pigment, you can't really get that off the spoon very well, so it's a silicon, this is the only decent part of the silicon kit that I got. So I'm going to try something. Rather than try and swish that off, what happens if I swish that up? And swish that around? Does that automatically suck it off of there? bother measuring, for goodness sake, we can zoom out now. Right. Don't put that on the string, don't put that on the string. I need the string later. Get rid of that. Let it zoom out. An epoxied clamp. That is too high. Right, I've now set that between -5 and 15 because we want it very, very low. It is not leaking out much at all, so the vacuum pressure isn't really dropping. And at the moment it's dealing with any air in the fibres, but it gives us the chance to massage these things into a place where they can be useful. This massaging is not going to be easy. There goes the vacuum pump. That's going to make our job harder, but not too much harder because it's stopped. So you can see I'm just, for better or for worse, pushing these things into place, sliding them across a metal table which is waxed, which it doesn't like to slide across. Just trying to get them in place. I'm only doing the outer ones first because they were the worst. Looks nice. So I'm massaging this in. The more time you spend with this, the better the result. Look where the corner is. This is a corner. That's so bad, I might actually just lift it up. Buggered if I know where those corners are. But I'm comfortably in But I'm comfortably uncomfortable. This is going to be either internal or undecided. I haven't decided not going to be a cosmetic one. But I do just want to do the best that I can. Not as much. Make as many mistakes all at once. To increase the university of life. Okay. Now, I'm going to increase the bracket. Falling program. So the high view minus 50. What we're going to do is check the movements during the body of this whole project. So that's perhaps pressure's relatively stable under the circumstances. So I'm going to go at 3 o'clock exactly. And you can see the infusion has started. Where's my clamping pipe? The clamping pipe on there. Right, there's some more tidying up. There's your sleepy bits. These are not small things, and they've gone walkabouts. Not in a way that my cat usually makes things like walkabouts. Right, all I can do is put the books away so that when I find them, I'm not looking for the box. Time I would seriously like to put gel coat in there just to see how well this system works on higher viscosity. I'm loving that I'm seeing resin running at a very fast rate of knots over here. Obviously is running all the way through there. It has got up to the midpoint here. Because we did fix a whole load of problems with the prototype, we did not fix the rip down around here. However, one of these. So I might just put a clamp or two here. Anyway, the vacuum is so much better. Right, now that that is running, reset this. And now take it down to -80. So I've now set that between -80, the higher end of the low pressure, and -70. At the start of the infusion, we really want to get this going. This is only one of the largest infusions that you will have seen on a tabletop. However, if this should become 90 centimeters wide by 2 meters long, you need that resin while it's as liquid as possible, whilst it's as malleable as possible. You need that resin to flow, which is why we have all of these channels doing all of the work that they're doing, all of the good work that they're doing. And you can see the beauty thing of this is that you can feel the bubbles running, and it's cat friendly. There's no resin, there's no wet resin except for up here. There's no smell being given off because it's all contained. There's no sticky fingers, there's no fixing leaks. You just sit and watch, or you sit and watch the TV. Which reminds me, something else I need to be doing for my own comfort right now. Now, all great ideas take place in certain places. Some call it the garden. It is actually preventing that from squashing that down. That's annoying. Either have it or don't have it. If you have it, make sure it's useful. Ugh. Might need to release. I'm actually able to manoeuvre that, so that should, in the end, turn out to be nice and tight. That's good. Now, this is a total experiment. We've never done this before, and there is no cloth for this to enter here. It has to find itself through plastic and through solid aluminium to get to the vacuum where the cloth is, because the cloth is not compressible, so it can retain spaces. And what we're trying to do with the vacuum infusion is to fill all spaces. There are no spaces here, except in these channels which are filled with resin. There are no spaces in the plastic except for 0.003 of a tiny hole to allow it through. There are no spaces underneath because this is on the table which has been waxed. So it could go through underneath, it could come up if it's able to get through underneath. So we're expecting to see this infused. It will meet the barrier of the cloth, but of the blue film, release film. But that's got holes in. The barrier is on the top anyway. Air can go through holes. Liquid can go through holes. Air can easily go through holes. So, with the cloth touching the aluminium, the base, we have no concerns about this being infused. Will it be infused equally? Well, that's something that we love about resin infusion, and it seems to happen that way. What we're not so sure about is what happens to these sides. Infusion doesn't really care about gravity. We'll probably do a video with this mounted vertically or upside down. It just doesn't care. So the theory is, if it hates a vacuum, nature hates a vacuum, and we're going to keep feeding it, it will fill up this vacuum with this resin until there is no more vacuum. And any cloth that is not properly impregnated will be a vacuum at some level. We have to check the levels here. The levels are looking okay. We may need to add some more in, which means we need to get some stuff out that we tidied away, but it is still worth tidying away. According to this, we're still recording. Of course, we can't not record. I can't charge the phone up in the sky, so when it's gone, it's gone. Until we come up with a better camera solution. This is a good camera solution. The reason why it's a good camera solution is that I can zoom in and out on my computer and I can see what I'm doing on my computer. The reason why it's a back solution is that compared to a drone. I can't change the camera. I need to nail a drone to the ceiling. I also don't know the difference between left and right. I have an X marks the spot. I need to nail a drone to the ceiling. That would be perfect. So they're flying. If they're not flying, then the camera would last longer, surely. Yeah, drone it is. Battery pack. I don't think I can see. No, I can't see a hole in the holder to get your juice in there. Now what I've just done is I've increased the vacuum. I've decreased the pressure. I've sucked out more moving things inside, so I've increased it to minus 95. I'm going to call that percent. I think it's minus 100, we can call it pure vacuum. So we'll now go down to minus 95. And, oh look, we've got some wet stuff going through. Wet, 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 wet. Minus 95. And if it reaches minus 95, it will give the pump a rest. It's only a small pump that we use here because it's only a small pump that we have to. We don't have a larger pump. That's heavy. We'll do that in future videos. So if it gets to minus 95, it will switch off and let the pressure drop inside the bag to minus 80. And then we'll switch it on and boost it up to minus 95. So that's the profile that we're using at this stage. So we use profile number 1, very low vacuum, and a very small amount of vacuum so that we can adjust things. Vacuum number 2, get things moving. Somewhere between 50 and 70, minus 50 and minus 70. Now we really want to get things moving because we're running out of time. It's always a race against time for this to be as liquid as possible. So we're minus 95, so that we don't stress the pump too much and then using small ones. So once it's invested in building up that vacuum, it can then, still only doing minus 15 kpsi, yeah, we'll call it psi. Look at it. It is pure. No, it's not psi. What if I manual gauge that? I can't be bothered to read it. Yeah, so minus 95, it just encourages it through faster. And why not? Why not? Because if there are any secondary leaks, air getting into the bag, and getting into the resin tube or air getting into the airline, and that comes up into the harder, that's the only reason. But we can't protect the air leaks, so we're right to do that, because the tightens off. Okay, now that that's switched off, let's get the pressure from the -70 max to -75 min. So it's not 100% vacuum, that's not required, it's just there with the clamping force. That puts less pressure. Okay, so I've clamped this. Okay, so I've clamped this off, fully infused, and still bubbling away, which is ideal. What I've done is reduced the vacuum system so that the maximum is -70, no, the minimum is -70 and the maximum is -75. That's just to take the wear and tear and pressure off the pump. It also gives me less interruptions to my evening. But it's not required. If we found that if we have this at -80, -90 kpsi, you'll actually get a dry part. It will suck the resin through the cloth and out the other side. We'll probably drop the increase the pressure, decrease the vacuum further throughout the evening. The harder this gets, the more set it is, the more you can reduce. It's now 6 p.m. in the evening. I would estimate that around 1 o'clock in the morning we could actually switch this off completely. What we'll actually do is probably drop it down to between -30, -40, -45 max. The reason for this is that the rotary vane pumps work so much more efficiently. They're just pumping out air. To get down to -30, it pumps that air out very, very quickly. 1 litre of air, half a litre of air. But to take it from -70, -80 to -90, it's really fighting, really struggling to work within that air that it can expel. If it expels a litre at -80, it doesn't contribute because you're actually removing a litre of vacuum. It's not rich and thick, Jeremy Clarkson. It's not the thick air that you find at sea level. It's the very thin air. So to remove a litre of thin air doesn't actually reduce the pressure that much further, which means that the pump has to run longer, which means that the oil gets used, all the components get used, and it overheats. And it interrupts the movies. So there's no need. The longer, the more set this resin becomes, the more it will hold its current shape. So you can hear the vacuum pump switching on and off in the background. That's because we've got automated vacuum techniques, which will machinery and electronics and sensors, which will bring to market. Get around to it. We'd like to make a product before we do that. But part of making the boat is the electronics that control it. So around the time that we produce a boat, we'll start mass producing the electronic control vacuum system, and programmable to take you through all of the different pressures, which you can then experiment yourself and check the results, because it's going to be so much easier setting up consistent tests. You just glue your foam, cut out 10 of them, cut your cloth, cut out 20 pieces if you want 2 layers, cut out and 10 of them, cut out 20 pieces if you want 5 of exactly the same. Just run it through, you'll get consistent results time after time after time. You can turn around these bags fairly quickly, they do require some cleaning. We've worked a long, hard journey to get it as easy as it is to clean at the present time. You then need to clean the table, which we use scrapers and vacuum attached scrapers, so that anything we scrape off, the majority of it at least gets put straight into the shark tank. You can see that there's very little components and wastage to throw away. We have this leading, I'll bring it into camera shot. We have this leading into the resin trap. There's a cup in there that collects all you need to do because it's a silicone cup. Or if it's a cardboard cup, throw the cardboard cup away. It's silicone, just remove the set epoxy. After 24, 36, 48 hours, put more cups in there. And then reuse those. You need to throw away the inlet tube, you need to throw away the inlet cup. That could be epoxy, that could be silicone, but until we produce our version of silicone, that will degrade any silicone cup much more quickly than the small amount that you see. Then it's not a good enough product. What is a good enough product? This. Inside, show you clean that over the bath. It is very static, so it is quite a messy process. Probably vacuum it first, but we can reuse the cloth. the only consumables in this process is the cardboard cup that we use, and the 2 tubes. No waste. And because you can keep adding resin, you don't, although there are calculators out there, it will only be by your own experience that you know exactly how much resin to use, how much you can get away with, and you know, the waste on this will be less than 5%, 10%. 5%, 10% sort of area. That's it, still fizzing away beautifully. I think it's reached the top of the resin cup. Still can't really see. Still looks clear. But that was a happy mistake. We cut the tube longer than needed to, found out that you could put this up on a shelf. Now we need to make it safe on that shelf. But great, something less that's in your way of seeing what happens. Those will go black or orange, some visible colour, dark blue. Looking forward to making those so that we don't lose the pieces inside. I think the other methods, you've got tape that you buy in 10-metre rolls, butyl tape, that's what I understand it's commonly called. You have various layers of this stuff, which we use too, so you can recycle that as well. But you have the outer bag, which has all of the folds and the flaps because it's not stretchy. This would be a stretchy film now. That would be an improvement. But it would be more expensive and it would be more impact on the environment to make something plastic stretchy when plastic is not stretchy. You also might change the properties so by making it stretchy, you might become something to epoxy resin, fibre, carbon fibre, all these things. as I leave you with the tones of the pump switching in and out and I go and watch some TV, I just wanted to leave you with the thought on timings. It's now 6 PM in the evening. I started this at 3 PM and may have started the infusion at 4. I can't remember. The point is that for the resins to be able to run through the cloth to get sucked through by the vacuum, it needs to have a long pot life. And the pot life degrades all the time. I don't know why or at what point. Because viscosity from the moment you mix it is increasing. It takes 24 hours to fully cure. It's still liquid, it's still blendable and malleable on this type of membrane. At 8 hours time, 12 hours, 14 hours, you can get to a point where if you do anything with timing techniques and temperatures, they don't very fly at the high temperatures. For Rolls Royce and they would need that sort of stuff. I would be speaking of that. But generally at comfortable room temperature, sometimes in the summer, 3 days of the year, it might be super hot. Generally, so remember, it is setting. Slowly, it starts slowly. You'll let yourself you might be fine you've actually got a fire hazard if this is too much. That is correct. So we need to material, but they also need to be able to run through the resin that has run through before. So I'm not sure, maybe we can colour code it at some point. If the first batch is blue, if the blue all migrates to the centre, or whether that if the second batch is white, if the white goes through the blue and into the centre within the blue bit. But the point is that you can't infuse after 3 hours, 4 hours, 5 hours, 6 hours. That's why the epoxy is so damn important. 90 minutes. It's okay for small parts. But as I said earlier, if this is 90 centimetres and instead of 50 centimetres it's 2 metres or 5 metres, then you have to look at different solutions to doing a one-shot molding because of the length of distance and the length of cloth. You have to engineer a different solution to be able to impregnate, to infuse the entire part in one go. And that's where you'll see much larger products than this, with pipes running all the way down the 2 metres, the 10 metres, constantly. It's actually just 10 sequential infusions really, but they have to use much more volumetric resin runs. The problem when you have that is that you need it to be slow. You need to have a controlled infusion to let the air through, even if you do gas, because it's off-gassing within the vacuum medium itself. That's brilliant. Leaving it to the perfect ratio, leaving it for a considerable period of time until the resin that's in the cloth is not going to, it's set enough to not get sucked through by the vacuum, but to be formable. So it's around between 8 and 14 hours that you can do. It's a sticky mess job, one that we prefer to avoid. But if we did want much tighter angles, the way to achieve it is with these compression inserts that we created. I've said so much about process today. Switch the camera off. It wasn't very effective, so if I just bring you down to see it from the ceiling where you can see the compression is used. I can get out of my own way. You get a much tighter 90-degree angle where the compression has been used versus where the compression hasn't been used. Bridging here. Get the transition. Slightly better lighting angle. Really nice, crisp, sharp angles. And for a modeless design. Model's design. So I do have a cup of tea getting cold.